Hi, this lesson is from page 287 in your student book, and the objective is student will be able to translate information in graphs to expressions. The essential question is, what steps do I take to translate information from a graph? The vocabulary word is linear. Linear is when a relation or a set of coordinates fall into a straight line. So it would be a straight line on a coordinate plane. All right, first example, what is the change in distance? Notice that our x is second, and our distance is the y. You would, to decide if it's linear, you would need to subtract the two consecutive y coordinates or numbers. And so 37 minus 18.5 is 18.5. 55.5, if you subtract 37 from it, you get the same number again. Sometimes that can happen though, so check all of them. 74 minus 55.5 is 18.5. And then I did the last one for you. And so because they are all the same, we know that on a coordinate graph, they would all fall in a straight line. And so you would say, yes, this is linear. All right, so this example is just a little more complicated, but notice the graph. And it says if you buy 1 yard of fabric at full price, each yard after that is on sale. Write an algebraic expression for this data. Notice the first yard is $5. The second yard, if you buy 2 yards together, you pay $7.50. And so we would say the first yard was $5, but the second yard only added an additional $2.50. So notice the first yard was $5. The second yard, those first two together are $7.50. Notice after 3 yards, and then after you buy 4 yards, your total is $12.50. So if graphs are new to you, notice number 4. You go up to number 4 and across, and it's in between the 10 and the 15, so you know it's $12.50. And then finally, notice after 5 yards of fabric, your total is $15. So remember from the previous lesson, to put that into an algebraic equation, remember you look at the change and notice that each time it goes up by $2.50. And so going up by $2.50 each time, our expression would be 250n. But then keep in mind you have to substitute that first number 1 term in for n. You only get 2.5 and you want it to be a 5. So how much more do you have to add? Another $2.50. So here's your algebraic expression. If that part doesn't make sense, then please ask tomorrow. And then how much would it be for 9 yards? You would substitute the 9 in for n, multiply those two together, and then add the another 2.5, and you would get 9 yards would be $25. All right, an electric train runs on a track 25 meters long. How long does it take to go around the track? Or, how far do you get each minute? And so notice, after the first minute, you go around the track 2.5 times. After the second minute, you've gone around the track 5 times. After the third minute, you've gone around the track 7.5 times. And see the pattern? Each time, comparing the y's, it looks like the y's increase by 2.5 each time. So we would say 2.5 times each minute, or n, would tell you how many times it's gone around the track. So how many times would it go around a track in 1 hour? you would think of that as 60 minutes. So 2.5 times 60 is 150 minutes, or simplifying that, 2 hours and 30 minutes. All right, Bruce's trip home. So notice this time our graph is descending. Here it is in a straight line, so we're assuming he went the same speed every hour or the whole time. So notice before he left for home, you would say he had 350 miles to go. After the first hour, he only had 280 miles left to go. So comparing the y's, it looks to me like the first hour he went 70 miles toward home. Let's see if that's consistent and linear. The second two, he went another 70 miles toward home. By the third hour, he's gone 140 miles toward home. Or I should say 140 left to go to get home. Sorry about that. How far would he have gone? He would have gone 210 miles so far. And so notice that he's getting closer to home. The mileage is getting shorter. And so to write an algebraic expression, you would say he gets closer to home, or my y is going down by 70 every hour. So you would want to say a negative 70 because my graph is going down and my y is going down. How far had he traveled after 2.5 hours? You would just multiply and you would say he had gone 175 miles. All right, translating words into an expression. Hopefully this part's a little review. Each term is 3 less than. Than always tells you that this part comes second, and whatever comes after than goes first. Twice the term. So twice the term, twice whatever the term is, less 3. Term would be the x on the graph. Then your answer, when you substitute first term, second term, third term, your answer each time is the y on the graph. So looking here, 1 times 2 is 2. 2 subtract 3 is negative 1. 2 times 2 is 4. Subtract 3 would be 1. 3 times 2 is 6. Subtract 3 is 3. Then you see the pattern going. Here's the same information. I just set it up for you so you could see how, but then I put the answer already in the t-table. All right, just a little summary if that's helpful to you. If you prefer to write your own summary, that's even better for you because you're putting in your own words, which is advantageous. And that's it. Great job tonight. I know it was a little bit longer, but good job.